All right, what's good, Joel? I think I'm almost done with like the pseudocode for this, and then when I have an interview today, so after I finish that, I'll probably go ahead and um, oops, and test it, cause I have to go to lab for that. Um, yeah. So let me go ahead and finish this. So the last one we have to do is not a. So let me do it like that, right? And then it is 0, right, and then okay. So we could say, why is that not? Oh, I see. That's why I had that uncommented, so I could get indentation right. All right, so it's gonna be win 111. Say that, and then it will be you need. Let's just make another variable. I don't even think this has to be signed, but I'm gonna do it anyway. So it would be like, it would be not hold gets the value of not a, right? And then it'll be if this should have a space. If, wait, can I delete and back? Cool. If not hold is 0, then 0 gets the value of 1, and then C out if not hold at the 15th lowest is 1, then if it's even, C out gets the value of the value of 1, and if, but that didn't fix itself. Okay. So also what was said in class is that if we get an output enable of 0, everything else is don't care except C. So let me make sure I did that. Port mode. Okay, so say we get an output enable of 0. So we would skip over all of this, and then we come here. And if else. Okay, and we only set C, so everything else is whatever it already was, which is fine. And interesting. I don't know what that's for. Okay. So by default, C out is 0. I think, can you set this up here? I don't have the linter for it, so it doesn't matter. But these should only be set like that if, because these are standard logics. So these should only be set like that on the first time that we run. Anytime else, we just keep it what value it is, and if we change it, we change it. If we don't, we don't. Because these are don't cares, you don't set them to 0. Or I guess you can, but he explicitly said that he did not want that to happen. Is there anything else in the ALU that I need to set? AB should are inputs, so it doesn't matter. Mode is also an input, so it doesn't matter. C is an output. Output enable is also an input. 0 and C out are the only ones that are output from the ALU. That are created by this. This already gets handled. So we're good. Okay, cool. So we are done with that. Let me go to the test bench. Because, yeah. I'll probably make a test bench for each one of these cases because all of them are different. So we should have, so for this, we should have, we should test the following, oops, this should have to do, oops, undo, G. So test the following edge cases. So we are looking for, actually, let me do it like this. So we're looking for full zeros. Actually, I don't need to do this. Full zeros. A negative and a positive. A negative and a negative. Or these aren't edge cases, but these are just normal cases really. Some of them are going to be edge cases. Positive and negative. Oops. Negative that sums to 0. We are looking for overflows in the negative and positive direction. And then what else? Parity is what? Yeah, parity is our carryout. What else? What else? What else? What else? Can't forget a positive and a positive. I think that's it. So that is what? 1, 2, 3, 4, 5, 6. 6 test cases at the minimum. So let's just do, wait, 1, 2, 3, 4, 5, 6, yeah. So let's just do test the following cases. Let's just make 10 test cases total, right? And then that will give us 1, 2, 3, 4, 5, 6, 7, 8. So that'll be, oh boy, that'll be 80 test cases that I have to write, but it shouldn't be too bad. So to remind me of that, I'm gonna make this 10, and that's gonna fail if I don't write out the test cases. Cool. So that's it for today. I gotta go to campus. Status. Man. Sudo is sudo done. Push. Okay, cool.